Hello everyone, welcome to my YouTube channel. I'm Rohit, and today we are going to discuss the explanation of double-slit experiment and wave particle duality, how DGR explains it. I am Rohit, and I am the author of this book, Rohit Kale, and this book is basically describing one of the new theories of quantum gravity and a potential theory of everything called as dynamic general relativity. So from this book, the dynamic general relativity, how it explains quantum mechanics, that is what we are going to discuss today. I would request you that it is a bit difficult for me to explain all these things. I don't really have many graphic images and all. So they are just hand drawings with which I am going to try to explain how DGR explains wave particle duality and weird findings of double-slit experiment. So you'll have to keep your imaginations on. And also there are some issues with it actually, because not everything we will be able to discuss in this particular video. But I'm going to, I think that you will get a bit of an idea how exactly, I keep on claiming that, wave particle duality of light as well as matter, it just pops out of the theory of the dynamic general relativity. Why I'm saying all that, why I keep on saying all that, a bit of it you will be able to know from this video. So let's start it without further ado. So we know what is a double slit experiment basically. So we know what is interference. There is basically a wave, especially the wave of light, which is passing. And when it passes through two slits, the wave diffracts, and again the second wave also diffracts from here. So it forms a single wave, forms two waves, and they interact. And then when they interact, some places the troughs meet troughs and crests meets crests. So the light might get exaggerated, or it might become completely dark. And so that is what you get alternate bands of light and dark. That's called as interference. That is very straightforward. And with only wave theory of light, this can very well be explained. There's not much of a problem there. The problem comes with not with the Young's experiment basically, which was described, but when we consider the other variations of the experiment, like the which way experiment or the delayed choice type of experiment or the quantum eraser type of experiment and all that. So anyhow, so we are not going to discuss delayed choice quantum eraser experiment today. Yes, and also one of the problems, one of the areas where problem arises is double slit experiment conducted with particles like electrons. So a wave of light exhibiting an interference pattern is very expected. So nobody will be excited, or be nobody will. But if an electron is also showing the same path, because people intuitively believe that an electron is like a tennis ball. So if a tennis ball is thrown, it cannot go from both the slits together. So it has to go from one slit or the other slit. And so it will not form a interference pattern. It should not form ideally. And if a single electron is passed, even then it should not form. But yes, even with photons of light, if a single photon is passed, even then the interference pattern happens. And more importantly is this second diagram basically. So as soon as so this interference pattern is seen even with a single photon or with an electron, and as soon as a measurement is taken, this is also very interesting. That what exactly do we mean by measurement? We can basically try to find out from which slit the electron is going. So whether it is going through the slit A or the slit B. So as soon as we try to measure, we can do potentially by two places. We can put a detector before the slits or after the slits. So delayed choice or which way experiment, whichever. So in either cases, what happens is that the electron or the photon loses its wave nature, and it basically what is called as is that the wave function collapses, and the electron, which is supposed to be in the superposition of multiple quantum states, forms a single entity or particle, and then the particle passes through one slit, and you get only basically the interference pattern disappears. Now it is a very big riddle. Basically, nobody can understand why exactly the quantum particles are behaving like that. And one of the typical explanations is that the electron is basically in a superposition, so it can go through both the slits at the same time and interfere with each other, which means that the electron is basically not a particle, but it's a superposition of a particle and a wave. Now, so this is basically the problem with the double slit experiment. No, I'm not going to go into too much detail of why, but yes, so we'll come to DGR, dynamic general relativity. If you have not seen my first video, that is the introductory video for DGR, I think that it's better that you watch that video before you watch this video, because whatever I'm going to tell now is given. I'm going to rush through today, so I'm going to just repeat it again, whatever is given there, but in a bit of a rush. So if you want to go in more detail of that, you'll have to see the introductory video. But anyhow, so there are some assumptions. What exactly is like DGR or dynamic general relativity? In that video, we had spoken that general relativity and dynamic general relativity, they seem very close actually, and they are close actually, but they are completely different theories, because at our level or human level or human scales, DGR looks exactly like that general relativity, so there is not much difference, no difference at all. But DGR is actually a dynamic theory. So whatever space-time changes are happening are actually dynamic. Means what? Space contraction is there. There's active loss of volume. In DGR, the quantum effects are there. So that is not basically described in general relativity. And so general relativity says that space-time is statically deformed, but actually what DGR says is that it is not a static deformation, but it's a dynamic deformation. Now how? I'll come to that. So basic assumption related to space of DGR is that the space-time is made of small granular like Planck compartments, which are made up of spherical or cubical compartments called as Planck compartments or PCs, which are one Planck length in length. So basically one Planck length, each side of the cube is one Planck length. So that's basically one Planck volume of space. So these are like marbles, but there are some very interesting assumptions of that these marbles are actually like marbles, because these Planck compartments are they are like marbles. So if one marble is already there in one place, so the other marble cannot take its place. So when you can so you can imagine that there are two marbles. So if there is a third marble in between that, then if the so one more assumption is that there should not be any space in between them. So that space in between them is not allowed. So PC vacuum, it's a true PC vacuum is not allowed. That is one assumption. So as soon as the Planck compartment in between them vanishes, the two will be pulled towards each other, so that the PC vacuum is compensated. But actually there you cannot compensate the PC vacuum by just shifting. So what happens is that the two PCs shift, but then the PC vacuum, when this PC shifts here and this PC shifts here, this is basically one Planck length. So this will shift half Planck length and this will shift half Planck length, which is actually one PC will be here, that will also shift, that will also shift. So basically this PC vacuum will be shifted from here to here. This PC vacuum will be shifted from here to here, here to here, like that. In that sense, the PC vacuum compensation is not actually compensation, is basically shifting of PCs. Now this is basically an assumption of DGR, that these PCs, although they are empty space, they are like marbles, so they cannot take each other's space. So if let's say there are two PCs and there is a small place point in between the two PCs, so there one PC gets created. So when a PC gets created, it cannot overlap with these two PCs, so it will push these two pieces apart. So basically any pull force is because of a loss of PC or destruction of PC. So if this PC is destroyed, this PC is pulled towards, and this PC is also pulled towards. So both are pulled towards each other. So wherever there is a pull force, there's destruction of so basically there is in the quantum foam there is constant destruction and creation and destruction and creation of PCs. And so that's why this creation to destruction, or C/D ratio, is very important here. So the universe is made up of two parts. That is manifest component, that is the Planck compartment, and the unmanifest component, which is basically the pull force, that is the PC vacuum. So this is 1 and this is 0, 1 0 1 0, like that. So everywhere in the P, and the whole universe is basically rewritten every Planck time of the universal time. So again, I'm not going to explain in too much detail about the local time part of it and the universal time part of it. So you'll have to go through the introductory video to explain, to understand that. So again, as soon as, so if you can see that there was a small destruction event which happened over here. So one PC is destroyed. So this first layer of PCs, layer 1, will be pulled towards each other. So what happens is that the PC vacuum from here is shifted outwards. So these cannot go inwards until they develop a volume loss. So there will be some volume loss here also. So here there is one PC loss of volume. Here there will be much more volume loss, but all that volume will be shifted outwards. So this basically at any point where there is a active volume loss which is happening will lead to what is called as entanglement of the PC. So these PCs will get entangled. So just outside the PCs get entangled and they are pulled inwards. So then again, PC volume is shifted outwards and the outer layer will get entangled, and the third layer, and the fourth layer, and the fifth layer, like that. So every entangled PC aggregate will lose surface area as well as volume, and it will go inward. So basically it will form what are called as time resetting waves. So whenever and at any point where there is a destruction, there is a T is equal to 0 compartment, there every Planck time of universal time, one Planck volume of PC, one PC or one Planck volume is lost, basically. So one PC is lost per one Planck time. So that is how the eddy Planck compartment aggregates, or EPCAs, are formed here around a place where there is constant destruction going on. So like that, eddy Planck compartment aggregates are formed, which are actually, these are basically time resetting waves. So there is time, local time, there is an active spatial contraction which is happening over here, which is active volume loss which is happening. So this and this can take up the place of this only with loss of volume and loss of surface area basically. So as this moves outwards, it will form a sphere, and every time that sphere it moves inwards, there is a loss of surface area as well as volume of the sphere, because the number of pieces forming this aggregate, thin, very thin place, one Planck compartment thick aggregate. So as it moves inward, so that is a layer of pieces which moves inward. So that's called as EPCA. So EPCA formation. So this is basically time resetting waves, which are EPCA forming time resetting waves. Time is reset there basically. So if there's an active spatial contraction, local time there will be dilated. So time will be dilated. Now, why local time gets dilated when there is an active spatial contraction? For that, you have to see the introductory video. But basically, what is happening is that any Planck clock, any photon clock which is kept in that particular region, very miniature Planck clock, what will happen is that the active spatial contraction will hinder the forward progression of the photon. So it will slow down the ticking of the photon clock, which means that there will be a illusionary slowing down of the photon clock, which is not actually slowing down the time, because time is the universal time will keep ticking. So universal time Planck clock will keep ticking in the same pace, but the local time there will be dilated. So local time dilation is correlated to active spatial contraction. So wherever there is a local time dilation, there is active spatial contraction. So what is energy? Energy is basically two types in DGR: positive energy and negative energy. Positive energy is what C by D ratio deviated towards destruction. That there is whenever there is an active loss of volume or active spatial contraction, that is time dilation. So any place where there is an extreme time dilation and wherever there is active spatial contraction happening, that there predominantly positive energy is present. And whenever there is a C by D ratio, that is creation to destruction ratio, is deviated towards creation, that is there is more active unbalanced creation, so there is more volume being formed. In this, what happens is that there is time contraction and active spatial expansion, so volume gain is happening. So this is called as negative energy in DGR. So very basic thing is T is equal to 0 compartment. There is one Planck compartment where every Planck time there is a loss of one Planck compartment. There is a volume equal to one Planck compartment is destroyed. That's called as a T is equal to 0 compartment. So why it is like that? Because time, local time, not the universal time, but local time over there has become 0. So there is a very basic unit of energy, positive energy in DGR. So there's another thing called as the T is equal to T max compartment. So what is T is equal to T max? Is basically a fundamental unit of negative energy. There what is happening is that one extra Planck compartment is being created. So there is a deviation towards a more creation. So C by D ratio is deviated towards creation. So there is one extra Planck compartment being formed. So every second, 10 to the power 43 Planck compartments, extra Planck compartments are being formed, which is a very, very significantly high number. So this is what is called as a T is equal to T max, or another name for that in DGR is called as ENE, that is exotic negative energy antiparticle. Now these repel each other actually. So T is equal to T max compartments. If they come close to each other, they will repel each other. They have negative volume, they have negative mass, and they cannot form aggregates. So like T is equal to 0 compartment, they can, T is equal to 0 compartments can form aggregates, but these cannot form any aggregates. They are basically dark matter, dark energy candidates. But anyhow, that's not relevant. So so basically, yeah, there's something called as a positive energy particle and a negative energy particle. So multiple t is equal to 0 compartments can come together. So when they come close to each other, they will basically keep sucking one Planck compartment thick EPCAs or Planck compartment aggregates, which are eddy. They keep sucking, so the Planck compartment layers will keep going inside. So when two are close to each other, they will start pulling each other and come close to each other. Now, how many t is equal to 0 compartments can form aggregates? So there is no limit to that. 10 can aggregate, 100 can aggregate, 1000, 2000, 10 to the power 10, 10 to the power 1, 1000, any number. So there's no, but you can understand that, you know, if only some are aggregated, then the energy density is much less. But there are much higher number of 10 t is equal to 0 compartments which are aggregated together. The destruction which is happening at that point is also very large. So there is something called as a t is equal to 0 continuum, in which, you know, very small number of t is equal to 0 compartments aggregated together, which means that there's a massless photons. As we more and more number of t is equal to 0 compartments aggregates form, the energy increases, so the frequency increases. That is basically the higher energy electromagnetic waves, like infrared, and then visible light, and then ultraviolet, and then gamma rays, and all that, X-rays and gamma rays. So you can understand that. After a particular amount of there is one, we don't know what exactly is the amount, but after a point, so much energy is basically concentrated at one point that it forms a particle with mass. So as soon as a particle with mass is formed, again this particle with mass can also further aggregate with multiple other particles with masses. And, you know, actually you can understand that what happens in a black hole is that it keeps sucking anything which, you know, is coming near its path. And this t is equal to 0 compartment is also basically doing the same thing, but it's basically doing it for space-time. That is the fundamental units of space-time, that is Planck compartments, which means that this t is equal to 0 compartment is actually very similar to a black hole. And slowly as the size, the amount of energy increases, the sucking tendency also increases. So basically you are looking at a bigger and a bigger black hole. So what our theory is suggesting is that there is a miniature black hole at the core of every particle with mass, or for that matter, particle which is a particle of light, that is a photon. So the only thing is the difference in energy. So there is much more energy in the particle, in the core of a particle with mass, as compared to the energy in the photon. So there is much less destruction. So there is destruction correlated to the amount of destruction per Planck time, correlated to energy. So this time resetting waves, any positive energy particle, or for that matter negative energy particle, it creates void. Basically, it causes destruction in every Planck time. So what happens is that time resetting waves start forming all around it. So these time resetting waves move outwards. Now, initially it was a thinking that, you know, these are time resetting waves. So general relativity would say that they would move outwards with speed of light, but the speed of light is actually very small. So it's a useless thing actually. So these are events which are happening at extremely high speeds. Basically, imagine that there is a particle, and this positive energy particle has 1000 T is equal to 0 compartments clubbed together. So what happens is there is a void of 1000 T is equal to 0 compartments. There will be rather 1000 Planck volume void will be formed in one Planck time. So in a single second, there will be huge amount of void created, which is useless actually. So basically, what I am trying to say is that compensating this particular particle with 1000 T is equal to 0 compartments combined together is with Planck compartments which are very lazy, and they honor the speed of light. It is very difficult actually. It is very difficult. So the ideal would be that these Planck compartments, because these are not particles with mass, so there is no compulsion, or there is no restriction which general relativity puts on how much should be the reaction time of them. So Planck compartments can react with PC vacuum formation at a very, very small time interval. That is, if a PC vacuum is formed in 1/1000th of a Planck time, they can react in that volume as well. Why not? Why does it have to wait for the whole Planck time to go and only then react? If that is the case, then a lot of void will be created, and it won't be. So it's very difficult to imagine this particular theory. So here, these time resetting waves travel outwards with extremely high velocities, much more faster than speed of light. But this is basically a time which is getting reset, and it's not basically. It's basically the active contraction of space. So active contraction of space, there is no limit set for it in general relativity. So this is basically a one Planck compartment thick spatial sphere which keeps on contracting and going inward. So this is called as the eddy Planck compartment aggregate. So how fast will it move? That can be faster than speed of light or slower than speed of light. So within the event horizon of a black hole, within it, the EPCAs will travel inwards faster than speed of light, so that even if a photon is accidentally it enters inside, it cannot move out of it, because the EPCAs within the black hole are moving inward faster than speed of light. So these are time resetting waves actually. So spatial contraction is the primary one, and the change in time is the secondary one. So this change in time is actually only limited to local time, and the universal time remains constant. Now, a static particle. This is a very typical figure. Basically, this is a static particle. Let's say this is a particle with mass. So let's say that 10 to the power 100 is the extent of the amount of T is equal to 0 compartments aggregated together in this particle. So what is happening is that there is such a high amount of destruction happening in this particular very small area. So there will be EPCA formation all around, and these small aggregates. So this particular represent one first volume of space, and second volume of space, and third volume of space. So each of these layers is moving inwards actually. So it keeps moving inwards. So it is basically moving like that, inwards. So this will be replaced. This particular thing will be replaced by. It will move inwards and it will replace this. Then it will replace this. Then it will replace this. Like that. Actually, it is not exactly replacing this. It is basically moving inwards. That's what we can say. But this is a static particle. So if it is a dynamic particle, it is moving, because all quantum particles are moving particles. So if they are moving, then there'll be a asymmetry basically. At one side, there will be much more inward movement than as compared to the other side. So here there is much more inward movement in this. And in our theory, momentum is basically this. So basically here, time is running with one particular time dilation. And here there is a different kind of time dilation. Here there is a different kind of time dilation. And time dilation is basically secondary. The main thing is that it is basically how much spatial contraction is happening. So spatial contraction is happening over here. So that spatial contraction is causing the time dilation over here. So here there is an asymmetry basically of time changes. So these time changes. So where in our theory, time changes is equivalent to energy. So this time changes which are happening over here are basically the momentum and the kinetic energy. Anyhow, so you can understand that if this is a photon which is moving in this particular direction. So not only it is moving because it is moving, it will basically follow the speed of light basically. So it cannot move faster than one Planck length in one Planck time. So it has to move in that particular with that speed only. But there is a huge amount of destruction going on over here. So because this destruction is going on, it has to be compensated. So these particular EPCAs or the time receding waves being formed are very high, and they will keep moving inwards. Now one has to realize that this is a wrong figure actually. This is I don't have any means by which I can explain. There are some mistakes in this figure. Definitely, this is a figure which is meant only for understanding purpose for the time being. This figure is not there in the book actually, because this is a wrong figure. Because this figure suggests something different basically. You can understand that this is you can say that this is a photon, but the photon can also have a spin basically. Not only that, you can think that this is an electron. So if this is an electron, then it will also have its own spin. It's a spin half particle, the electron. So if it is having a spin, then it's very difficult for me to show it here in this particular diagram. So if this particle has a spin, then you can realize that this particular this particular two diameters basically dmin and dmax, you can say. So here there is a much higher inward velocity of EPCs, and here there is a lesser inward velocity of EPCs. So this is dmin and this is dmax. So if the particle is spinning, so where dmin is there and where dmax is there, that point will keep on changing. So that is the reason why the wave will not exactly be like this. The wave will be waxing and waning wave, that is at places. So as it moves outwards, there will be places where there is more inward velocity, and there will be places where there is less inward velocity. Actually, so that's how the wave is actually very similar to sound waves. Actually, sound waves are what? Pressure waves, pressure difference waves. So here it's not pressure difference wave. It is actually time variation wave. So every point over here has a different time, local time, and it's actually local time is basically a measure of how much active spatial contraction is happening over there. So what is the C/D ratio at each place? So every point over here will have a different C/D ratio. So C/D ratio will be constant here, and there will be a different but a constant C/D ratio here and also here, like that. So this basically creation to destruction ratio will decide how much active spatial contraction is there at each place. So that is how the wave will actually have a waxing and waning actually. So this is not a completely true representation of that. But anyhow, this is good enough actually. So these are the EPCs, and these are the time receding waves which are moving inwards. So the time receding is moving outwards, but the Planck compartment aggregates are moving inwards basically. These are like layers of space-time which are moving inwards. So as soon as the wave reaches here in the slit, there will be a void created over here, and there will be another wave which is created over here. So the electron moving from one slit is okay, but the wave which is associated with the electron can move from the other side. So the the electron, although it will come from only a single slide, the ultimate location on the screen of the electron is decided by the status of spatial contraction, which is basically decided by the time dilation. So here again, spatial contraction and time dilation are related. So if there is a place where there is, let's say we have created a imaginary time over here. So if there is a point in the wave where the time dilation is 10, and then there is another point in which the time dilation is just 8. So when the two of them meet together, what happens is that the time dilation will add up. So the resultant time dilation will be 18, right? So if there are places where in this particular way where there will be excessively additive time dilation, which will mean that there will be much more spatial contraction there. But at some places there will be rarefaction, that is much less time dilation regions coming together. So there will be much less time dilation over there. So there will be much less spatial contraction over there. So the distribution of time which happens because of this interference here will basically determine what is the ultimate position of the electron on the screen, which is basically the interference pattern. So the electron will show the interference pattern, although the electron is passing only through one slit, and even if the electron is passed through a single, one electron at a time, the electron is basically having a positive energy core within it, which means that there is an active destruction going on. So there is no question of not having a wave around it. So because it has mass itself means that there is EPC is going around over here, which means that there will be a wave associated with the electron. And so it very nicely explains. Now, what about measurement? So basically here, whether it's a photon or whether it's an electron, to measure it, you need to pass some another wave of light or maybe some another thing. So for detecting, you have to basically intervene in this particular place. So if you are intervening in this particular place, then you are basically intervening with the this particular pattern of waves over here. So if you are intervening and you are basically interfering with the pattern, then it will basically lose the interference pattern, because so that's what it means by collapse of the wave function, because this wave function is the one which determines the probability of where the electron will be more. And so it's basically, you can see that there is an actual wave which is not exactly a carrier wave, because the electron is like what the pilot wave theory says is that there is a wave which is just traveling and it's not related to the electron, but it is basically being carried by the electron. Now this is not very different than what it is, but the electron itself is having a lot of energy in it. So it is the one which creates this wave basically. So it's not a wave which is traveling and it's taking the electron with it, but actually the wave is being created by the electron. And another thing to note is that here the transfer of information of time is traveling much faster than speed of light. You cannot have speed of light transfer here, because it will fall short. Basically, it will fall significantly short. So here DGR is basically saying that the electron has a wave associated with it, but it is a real particle. So it's a non-local thing basically, because the transfer of information of time is basically happening much faster than speed of light, which means that it's a non-local realism. So this theory basically supports non-local realism, and there is definitely no question of there's no question of superposition. The electron has a position, but the position of the electron can change extremely rapidly, not faster than speed of light definitely, but it can it can change maybe 5 or 10 or 15 or 20 Planck times. The position will change, which means essentially that you won't be able to, basically it explains why you cannot get an exact position of the electron, but you get a probability of position of the electron. So you can imagine why quantum mechanics is showing us a probabilistic thing, but that doesn't mean that the particle is not real. The electron is very real, and it will have its own particular location at every Planck time, or even smaller than that. So the location of the electron can be is basically, according to this theory, known to nature in a pretty accurate manner, as close to Planck scales basically. Okay, so delayed choice quantum eraser, I have it is not clear yet actually what exactly, because it's a very complicated experiment, but we will have to have a working model, and then you will have to look out for each and every wave front moving and all the entangled photons and all that. Here, the delayed choice quantum eraser, much faster than speed of light transfer is possible. But here, one thing is clear, that dynamic general relativity is there is a universal time in dynamic general relativity, which means that whatever local time is there is actually because of active spatial contraction or dilation. So spatial contraction or dilation is the reason why we are getting an illusion of change in time, but the change in time or the relativity of time is actually an illusion. It's not real. So there's no question of passage of information in the past basically. So the speed of the arrow of time is very well defined in dynamic general relativity, and there is no question of retrocausality. That is one thing. Second is dynamic. It's a bit difficult to know at the moment how exactly DGR would explain delayed choice quantum eraser experiment. Anyhow, the question is that there's no reason why superposition should be there. So there's no reason why, I mean, for DGR, electron going through both the slits directly is out of question. But yes, the electron, the wave created by electron is going through both the slits, and the wave created by the electron is basically the one which is getting intermingled, and interference pattern appears because of that. And essentially DGR is pretty much close to Bohmian mechanics, which is basically like a pilot wave. Okay, and it's a realist theory. So I hope that I at least some part of this is clearer, and I think so there are quite a few things which are not clear yet, even now in DGR, and also there are quite a few things which I have not been able to tell in this particular video. So this is not the end of it actually. There's much more in the book. So I recommend that you read the book if you want to know more about it, and I also recommend you before you read the book, you should also go through all the psychology related videos, because psychology is one of the main hurdles. And I recommend that you subscribe and share this video as well. Subscribe, because if you have the if you want to know more about theory of everything and why DGR and what are the highlights and all that, then I'm going to keep uploading a lot of videos in this particular channel. So it's better that you subscribe. It's better that you buy the book, definitely, but if you're not buying that book, at least you can subscribe so that you can get an idea of what it is. But remember that this is the in thing, and it's going to be the future of physics. So I think that you should go through the book, definitely. So thank you very much for your attention, and have a nice day.